As agents begin to coordinate tasks, make decisions, and operate across systems, the impact of AI won't just be technical, it'll be economic and social as well. Joining us next is David Rothschild, an economist in our New York City lab. David is going to show us how agent-based systems reshape coordination and markets, and how we can guide this transition towards open innovation-driven ecosystems that benefit society as a whole. This research looks beyond technical performance to the larger question: how do we ensure AI drives meaningful, positive impact at scale?
Hi, my name is David Rothschild, and I'm an economist at Microsoft Research in New York City. And I'm here to talk about actually a series of papers that I have been working on with the team out of New York and New England in economics and computation. And we're super excited about this work because rather than focusing on just the short-term impact of AI, we have had the opportunity to look long-term, very broad, about what happens when AI becomes more ubiquitous. What happens when agents become more ubiquitous? How does that affect markets, society? How does it affect all of us? And let's start with the puzzle. AI capabilities feel extraordinary, yet large-scale economic disruption still seems muted. Our explanation is not about model quality or even the harnesses that are increasingly used to capture the processing power, although there's obviously a lot of advancements to come. It's about how AI is being integrated into workflows. First key point. We distinguish three phases of disruption. In this first stage, augmentation, AI speeds up and improves individual tasks, writing, summarizing, coding, inside of workflows built for humans. And in the second stage, automation, routine tasks move under the hood. Humans monitor at a high level, but the underlying architecture, forms, approvals, queues, they remain unchanged. It's still the same human-centered workflow and has the same human-centered then blockage that makes it hard to really hit into the next level of disruption. That's what you get in stage 3, reconstruction. That is where the real disruption happens. Workflows and markets are redesigned from the ground up around AI's native strengths: parallelism, memory, continuous monitoring, and machine-to-machine interactions. You don't need to build the UX for humans anymore. And the key claim is that most observed gains so far are in stage 1 and kind of moving into early stage 2, while the largest welfare gains, the things we're going to remember about this disruption, well, they're in stage 3. And that stage is institutionally hard to get to. So that goes to our second key point. As I just alluded to, the binding constraints to getting to stage 3 adoption are not necessarily technical. Reconstruction of workflows around AI requires delegation of real authority, trust and accountability infrastructure, machine legible data and constraints, and incentives that reward redesign rather than local optimization. Is getting through that innovator's dilemma and really killing what you have and creating something completely new. So similar to general purpose technologies that come before it, from electricity to computers and the internet, AI disruption has a long adoption arc ahead of it. And that bottleneck is complementary organization and governments, not necessarily raw capability. Third key point. As the AI disruption moves into stage 3, while the leaps in data access and processing power continue to take our attention, it's coordination frictions that become the key policy and design choice. What do we mean here? The lower the communication friction, the lower the lock-in, and the more we unleash widespread coordination of microtasks and payments, the larger are the returns to innovation, and the more equitable the welfare gains are to businesses and consumers, rather than the central platforms. Incumbents benefit from constraining agent interaction, while society benefits from reducing it. The structure of future intermediaries, are they going to be open or are they going to be closed? That is what is going to determine whether AI amplifies competition in welfare or concentrates power behind artificial bottlenecks. Similarly, for workers, their surplus also depends on how this delegation, monitoring, and entry are governed. Fourth key point, the scary one. The default trajectory favors entrenchment. Incumbents with existing consumer access are incentivized to maintain control of a market share. And while the organizational and government investments required for open and safe agentic ecosystem, well, they're pretty costly and they're difficult to coordinate. The result may be speed without restructuring, AI that accelerates today's platforms rather than rebuilding them, really sticking us into an endless stage 2. So how do we get to the good place? How do we get to a place in which there is widespread growth and equitable distribution of that welfare? For us, that means building synthetic agentic markets capable of studying and maybe even influencing how different paths to stage 3 can evolve and what do they mean. This is the good thing. For the most part, agents don't know they're in a lab. So there's a lot of external validity to this work. These environments allow consumer assistant agents to interact with business service agents through markets with end-to-end under controlled conditions. And the value of this approach is that it allows us to directly observe things that would otherwise be confounded in the wild. For example, in these synthetic markets, we can examine how market outcomes change when the interaction shifts from human to agent to agent coordination, and what breaks when agents are given real authority rather than just advisory roles. Which government mechanisms, constraints, monitoring, auditability are necessary for humans to provide agency to agents? And this is not always the same threshold, but what is the necessary capabilities for this delegation to work? And of course, you can put that all together, and then you got to look at how red teaming works. What happens when you add malicious actors to the mix? These experiments make reconstruction claims concrete. They show that the ability to add AI just on top of existing workflows is there, but it doesn't produce the same sort of results that you get when you rebuild that interaction layer to really take advantage of what AI has to offer. And so alongside the lab work, we've been developing formal theoretical models as well. And these allow us to study agentic markets at a higher level of abstraction. The role of theory here is not fine predictions. It is about comparative statics. The models allow us to isolate key design choices that are difficult to vary in experiments at scale, such as open or closed ecosystems, centralized versus decentralized discovery, with varying feedback mechanisms, different degrees of delegation. They also drive the experimentation that we try, right? So the theory helps drive what we experiment on. And what emerges is consistent. Architectural choices shape equilibrium behavior and surplus allocation. And this is even holding AI capability fixed. So what are the key takeaways? AI disruption is real, but delayed compared to what you may think. Its largest effects will live in this stage 3 reconstruction, not at task level acceleration. And it's not easy to reach the future. Understanding that transition requires a mixed methods. It requires systems thinking and lab experiments and theory all together. And when we do that, what we see is that we need to help not just skating towards the puck, but directing that puck to a place that is going to give higher welfare gains and more equitable welfare gains. Waiting is itself a choice. Early architectural decisions are going to harden quickly, and those are going to have long-term implications for the economy, for society, for all of us. So thank you.